Hello students, welcome to the channel. In today's Basics Explained video, we discuss functions. Functions are an important part of both SET and ACT math, so it's important that you get comfortable with them. So how do we define a function? A function, which is defined by the notation f of x, is any operation that you perform on the variable x. So for example, f of x could be x squared, which is to say that if I input 2 into the function, I get the square of 2, which is 4. F of x could be 12e to the power x, where e is the constant 2.72, known as Euler's number, plus 7x cubed. So here, if I enter 1 in this function, I get 12e plus 7. This is the value of the function at x equal to 1. So any operation done on a variable is what a function is. Now, fx is equivalent to y when we define the function as an equation. So let's say I have a straight line equation where I say y is equal to mx plus c, where m is the slope and c is the y-intercept. Then this x and this y can also be denoted as f of x. So I can also say f of x is mx plus c, because that is effectively what we are doing to x to get the value of y. So fx and y are equivalent. Okay. Now, function notation involves figuring out the value of the function at different points. So for example, if I have fx defined as 2x plus 5, then f of negative 3 will be 2 times negative 3 plus 5. So wherever I have x, I'll replace that with negative 3. So that's minus 6 plus 5, which is negative 1. Okay, what about f of x plus 3? Now, f of x plus 3, by the same logic, wherever I have x, I would put x plus 3. So I get 2x plus 6 plus 5, which is 2x plus 11. So you just need to put the value wherever it's x. You replace that with x plus 3. Okay, then we have something called nested functions. Nested functions work like this. So let's say f of x is 2x plus 5 and g of x is 3x squared. Then f of gx is gx becomes the subject of f. So whatever is gx will be the subject of f. So what is gx? Gx is 3x squared. And this is now the subject of f. So wherever I have x in the function f, I would replace that with 3x squared. So I would say 2 times 3x squared plus 5. So that's 6x squared plus 5. So f of gx is 6x squared plus 5. Let's try and find g of fx. So how do we find g of fx? The same logic, this would be g of fx, which means the value of fx becomes the subject for g. So f of x is 2x plus 5. So 2x plus 5 becomes the subject for g. So wherever I have x in the definition of g, I would replace that with 2x plus 5. So I get 3 times 2x plus 5 the whole squared, which is 4x squared plus 25 plus 20x, because a plus b whole square is a square plus b square plus 2ab. So that's 12x squared plus 75 plus 60x. So this is the definition of g of fx. Okay, let's go on. Now, what is the remainder theorem? The remainder theorem says that if you have a function fx and you divide it by x minus a and you get the remainder p, then the value of the function at x equal to a is p. What do I mean by that? So let's say I have a function f of x is equal to 4x cubed minus 5x plus 1. And what will be the remainder when this is divided by x minus 2? That will be the value of the function when x is 2. So if I find f of 2, that is 4 times 2 cube minus 5 times 2 plus 1, which is 4 times 8 minus 10 plus 1, 32 minus 9, which is 23. So when I divide this function, 4x cubed minus 5x plus 1 by x minus 2, my remainder is going to be 23. And what is the corollary from this? If x minus a is a factor of fx, then the remainder should be 0. So if x minus a is a factor of fx, then fa is 0. And we already know that if the function is represented as x minus 2 whole squared, x plus 1, x minus 3, then f of 2, f of negative 1, and f of 3, all these three are 0, because when you put x equal to 2 or negative 1 or 3, the function becomes 0. So the remainder theorem also leads you to the fact that a factor of a function is one where when you put that value into the function, you get 0. Okay. On the SAT and ACT, you would also be tested on function graphs. I have an entire video on algebraic graphs, which I would link to in the description box below. But let's look at this question here. The complete graph of the function is shown in the xy plane above. For what value of x is the value of fx at its minimum? So I can see that the minimum value of fx is here, and that value is negative 2. But this happens when x is negative 3. So for what value of x is the function at its negative? It would be negative 3. Remember, they're not asking the minimum value of the function. That, yes, is negative 2. But the value of x when function is at its minimum, that is negative 3. Okay, let's do some sample problems. The table below shows the values of the functions fx and gx for two values of x. Find h pi by 4 if hx is fx times g tan x. So h pi by 4 is f pi by 4 times g tan pi by 4. Now, if you work with radians, then pi by 4 radians is 45 degrees and tan 45 is 1. So this becomes f of pi by 4 times g of 1, because tan pi by 4 is 1. Now f pi by 4 from the graph is negative 2, and g of 1 from the graph is negative 3 by 2. So h pi by 4 becomes 3. Right? That's how you can get the answer 3. Okay. Question 2, if f of x is 2x squared minus 2 and g of x is 2 to the power x, what is the value of, one second, what is the value of g of f0? So let's first find f0. f0 will be 2 times 0 squared minus 2, which is just minus 2. So f0 is minus 2. So we now need to find g of negative 2, because whatever is f0 becomes the subject for g. And g of negative 2 will be 2 to the power negative 2, which is 1 divided by 2 squared, which is 1 by 4. So the answer for this question is 1 by 4. Okay, when 2x squared plus 3x plus k is divided by x plus 1, the remainder is 2. What is the value of k? So here I can use the remainder theorem. remember that I would have to write x plus 1 as x minus of minus 1, right? Because when I do the remainder theorem, I say that when fx is divided by x minus a, then the remainder is f of a. So here a will be negative 1, right? Because x minus of minus 1. So if this function is f of x, then f of negative 1 would be 2 because the remainder is 2. So 2 times minus 1 squared plus 3 times minus 1 plus k is 2. So 2 minus 3 plus k is 2. 2 and 2 cancels. So k is 3. Okay, let's do one more. F of xy is xy divided by 3 for all xy. So here we have a function which is defined on two variables, x and y, and the function is the product of the variables divided by 3. Now, f of a comma a is 3. So f of a comma a is 3, and f of b comma b is 27. A is negative and b is positive. Which of the following is the value of a plus b the whole squared? So f of a comma a would be a squared by 3, and that's 3. So a squared is 9. So a is plus minus 3. But since a is negative, I would take negative 3 for a. Now similarly, b squared by 3 is 27. So b squared is 81. So b is plus minus 9. But since b is positive, I will take plus 9 for b. So a plus b the whole squared would be minus 3 plus 9 the whole squared, which is 6 squared, which is 36. So the right answer is option C. So that was a quick explainer on functions. I would link to algebraic graphs and also advanced problems and functions in the description box. If you found this useful, please hit like and subscribe to the channel. I'll see you in a new video soon. Take care. Bye.